Right. So in this question, it says in 1915, 4.2, a more realistic model predict the world's population. A logistic model, the table below records the population at 35-year intervals, okay, which is unusual, because usually the gap is equal to 1 year. Okay. But in this particular case, the gap is equal to 35 years from one population cycle to the next. Okay. So, right. Sorry, I'm just waiting for the video to get cracking. Okay. Right. So sorry about that. So normally, as I say, the gap in between the years, okay, is 5 years over there. Okay, each is 1 year per population cycle. Okay. But in this particular case, the gap is 35 years. Remember also that delta P is an average gradient around a point. Okay, that's a really important concept that you've got to understand for the logistic model. So delta P is your average gradient around the point. So if we look at 1950, okay, they tell us delta P, they give us the rate is 0.054571. Okay. So to figure out, okay, remember on your axis, sorry, you've got gaps of 35 years. Okay, you've got your population on the y-axis. Okay, so what they're telling us when they tell us delta P is 0.054751, how they would get that figure over there. Okay, the way they got that delta P is you're looking at the average gradient around 1950, because we're looking at that point. Doesn't even have to go through 1950. So that's how, to get that figure of 0.054, they're saying average gradient is change of y over change of x around that point, around 1950. So they'll go 5,12 minus 1,3 over 35 years. Okay, so 70 years. 1985 minus 50, so over 70, and that's how they get that rate of 0.0571. So to get A itself, well, we're looking for the logistic growth rate at 1950. So it's the average gradient around that point divided by the population at that point. So A is equal to delta P over P. So in this case, it's 0.054571, all divided by the population. And the population at that point was 2,52 billion. And if you get that, you get the logistic growth rate at 1950, which is 0.021655. Right. The next thing is we need the average gradient around 1985. Okay, so the smooth growth rate around 1985, the average gradient. Okay, so to find, so we working around 1985. So we're looking at the point to the left of 1985, okay, which is at 1950, 2,52, and we're looking for the point to the right after 1985, which is 2027,22, and delta P represents the average gradient between the 2 points around 1985. So to find B, it's going to be change of y over change of x, which is going to be equal to change of y is 7,22. Okay, it's always a one after minus the one before, so 7,22 minus 2,52 on the table. That's your change of y. Your change of x is 2020 minus 1950. Okay. So from around 2020 to 1950. So we're going to end up with your gap between 2020 and 1950. So 2020 minus 1950. And so your change of x, as I say, it's normally equal to 2 because you go, normally in the population cycles, the bottom number is 2, but in this case, it's not going to be that. So we're going to go 2020 minus 1950, and we end up with a value for B, your average growth rate around 1985 as being equal to, so the average grade, so you're normally going to do the one before, the one after if you don't have the graph, okay, divided by the change of x, which is the change of population. Okay, you work that out, and you get an answer of 0.067165. Okay. Right. Then, okay, sorry, 0.067143. Then we're going to go find the value of C. Well, C is just going to be equal to 0.067. Okay, it's going to be equal to delta P, 0.067143 divided by, okay, the population at that point, and the population at that point is 5.12. And if you work that out, you should get 0.013114. Okay. Now we've got C. So there are two ways we could go find D. Okay. And D is the average gradient around 2020. Okay. So the one way is to do what we've done before. Okay. We're not going to use a graph for that. So D is change of y over change of x, the average gradient around 2020. Okay, the change of y is 10,12, the one after minus 5,12, and your change of x is the one after minus the one before, 2055 minus 1985, which is another 70 years. And you work out D, and you should get an answer of 0.071429. So you could do it like that, or you could use the fact that you know the population, P, and you know delta P over P. Okay, so we know the population at that 2020 is 7.22, and we know the delta P over P value. Okay, so we know that delta P over P, okay, so we've got P is at 7.22. Okay, and we've got delta P over P, we know is equal to 0.0983, whatever it is. Okay, so I end up, okay, in order to figure out, so you end up with delta P over P, so it's going to be delta P over 7.22, okay, is going to be equal to 0.009. You have to show all this working, 893, don't round off. So you end up with delta P is equal to 7.22 times 0.00983, which is going to give you the same answer, 0.071427. Okay. Right. And that is that question. Okay. But a common question. Hope you're comfortable with it. Okay. All right.